In this video, we will learn how to calculate standard deviation. Standard deviation is important for when you write lab reports, as you will almost always have to calculate standard deviation of several results. So for starters, what is standard deviation? Standard deviation is a quantity expressing by how much the members of a group differ from the mean, or in other terms, average value of the group. While there are several formulas with the same premise for standard deviation, we will be using this one, as it is arguably the simplest one to read for beginners. Do not be intimidated by the formula. The legend for the formula is as follows: S represents the standard deviation, sigma represents the sum of xi and x, squared for xi representing each of the values in the sample and x representing the average of the aforementioned values, while n represents the sample size. Since a brief description that is being described by a robot is not enough to understand, we will solve an example question. Example: calculate standard deviation for the value pool of 16.7 milliliters, 15.8 milliliters and 19.5 milliliters. These example values are ones that you can come across while doing a titration experiment. For step 1, we will find the sample size, n, which in this case is 3, as we have 3 sample values. This goes in the bottom of the fraction equation, as n-1. Next, we will find the mean or average, x. To find x, we will combine all the sample values, and divide it by the sample size, n, which we have already found, giving us an end value of 17.33. Now that we know the two unknowns, n and x, we can plug in our values into the formula. First, put every sample value into individual parentheses, subtracting the average from them, then squaring them. Then combine these values, and divide by the sample size -1. Finally, take the square root of the value and you will find standard deviation. As a fellow student, I advise that you use a scientific calculator to do these steps, as doing them by hand is incredibly impractical, and using a conventional calculator will take far too long. When you plug in the given formula, you should get a value close to 1.9295, which may deviate slightly, unintended pun. Now, calculate these two exercises yourself and check your answers. Pause the video and check in after you calculate them. For exercise 1, you should get a standard deviation value around 0.1096, while for exercise 2 you should get one around 0.3109. Thank you for watching. In the next video, we will be learning how to calculate relative standard deviation, also abbreviated as RSD.